Today we're going to cover section 3.1 of our Algebra 2 BJU Press textbook, and we're going to discuss relations. So we're going to begin with a familiar concept. We're going to talk about the Cartesian plane. This is how you spell Cartesian. So a Cartesian plane is composed of two reference lines. We have the x-axis and the y-axis. So it's composed of two basic reference lines. And those lines are the x-axis and y-axis. Okay, so this plane, it extends indefinitely and is divided into four quadrants because the two axes, the x-axis and the y-axis, they're going to be perpendicular and then they're going to create four quadrants. Okay, so the important components of the Cartesian plane, I'm going to go over with you now. So here is the y-axis, which is the vertical reference line. Then we have the x-axis, which is the horizontal reference line. The point in which those two reference lines meet is called our origin. And then our four quadrants, they start in the upper right-hand corner, so quadrant 1. And then we go counterclockwise, and we're going to use Roman numerals. So quadrant 2 is in the upper left, and we use a Roman numeral 2. And then lower left is quadrant 3. And then lower right is quadrant 4. Alright, so points in the plane are named by ordered pairs. So points in the plane, so points in the Cartesian plane are named by ordered pairs. So ordered pairs look like this. There's an open parentheses, an x value, comma, and then a y value, and then close parentheses. So the first number in an ordered pair, we call that the x coordinate. And then the second number in an ordered pair is what we call the y coordinate. So if we want to locate a point on the graph, we move horizontally x units and then we move vertically y units. So think about your alphabet. You move x first and then you move y because x comes before y in the alphabet, and the x is horizontal and y is vertical. Another way to remember is the y is long. A y is long, so that means that it is up and down vertical, whereas an x is flat, which means that it is the horizontal. So those are easy ways to remember which way are we going, which one's the x, which one's the y. So again, to locate a point, we move horizontal first, horizontal x units, and then we move y units vertically. And then remember that positive is right for x and up for y. All right, let's do some examples. we will start with example 1. And it says graph A, point A, which is 2, 4. And then graph B, which is 3, -2. Then graph C, which is -1, 0. And then graph D, which is -3, -4. So we need to graph those points. Okay? So step 1, we need to draw a Cartesian plane and we need to label it. So here's our plane. So here's our y-axis because it goes up and down, it's vertical, and here's our x-axis. Okay, so we've drawn it and we labeled it. Now we're going to plot what's called plotting. We're going to plot A. So to plot A, we start at the origin, and then we're going to move 2 units to the right because it's a +2, so 1, 2. And then we're going to move 4 units up because it is a +4. And so that point right there is going to be A. So again, 2 units and then 4 units. And that got us to A. All right. Now we're going to locate the other points. So let's start with plotting B. Okay. So B was 3, a +3, which means we're going to move 3 to the right. So 1, 2, 3. Now -2, which means we need to move along the y-axis, but negative. So if positive was up, that means negative is down. So we're going to go 1, 2, and now we have point B. So now we need to plot point C, which is -1, 0. So the first thing we want to do is move along the x-axis. Our x-coordinate is -1. So we're going to move to the left 1. And then we need to move our y-coordinate, which is 0. Well, if it's 0, that means it's not going to move up or down. So we're right there still on the x-axis for point C. All right, now we are going to plot point D, which is -3, -4. So we're going to move to the left -3 because that's our x-coordinate. 1, 2, 3. And then we're going to move down 4 for our y-coordinate. So 1, 2, 3, 4. And that is our point D. So now we have plotted all 4 points. So graphs provide a picture of what we call a relation. If we want to graph a relation, let's say we wanted to graph the relation (2, 4, 3, -2, -1, 0, -3, -4. Let's say we have those directions. Graph the relation, and it gave us this. So it looks like a set with ordered pairs in it. All we would have to do is do what we have just done. That is graphing a relation. Okay, so we should also be able to write down a relation given a graph. If we are given a graph, we should be able to look at that graph and then write down a relation. So let's do an example of that. So we want to give a relation of the graph. And this is the graph that we're given. So this is graph A. as a y-axis and an x-axis. We've got some points here. So this point is at 1, 3. This one looks like it's at 3, 2. This one's at 3, -1. And then we have one at 5 and 4. Okay, so to graph this relation, first we name our relation. So the name of our graph is A, so we're going to use that name of our graph to name our relation. So now we're going to say A equals, and it's going to be a set of ordered pairs. So we're going to use our bracket to show that's a set, and then we're going to list the ordered pairs that we see. So we know this is 1 to the right, and then up 1, 2, 3. So positive 1 to the right, and then positive 3 up, which gives us the ordered pair 1, 3. So then we're going to do our next ordered pair. So we go 1, 2, 3 to the right, so that's positive 3, and then 1, 2 up, so that's positive 2 for our y. Then we'll do the same thing down here. We go 1, 2, 3, positive 3 to the right, but then we're going to go down 1 or -1 for our y coordinate. And then our last coordinate, we have 1, 2, 3, 4, 5 to the right. So our x coordinate is 5. And then we go up 1, 2, 3, 4. So that's positive 4 for our y coordinate. And then we're going to close our set because we have all of our ordered pairs. And now we have named our relation. So let's try one that's very similar to that. We're going to do graph B. And graph B looks like this. We have a coordinate plane with a y and an x-axis. And it looks like we have a point here at 2, 1, and then another point at 3, 1. So when we name this graph, when we name this relation, we're going to call it B because it's graph B. And we're naming a relation, okay, so we're giving the relation, so we're going to go ahead and use our set brackets. This is a set of ordered pairs. So let's find what our ordered pairs are. Our first ordered pair for our x-coordinate, we had to go 2 to the right, which is a positive 2 for our x-coordinate. Then we had to go up 1, which is a positive y-coordinate for 1. Let's look at our next ordered pair. This one, we had to go 1, 2, 3 to the right, which makes our x-coordinate a positive 3. Then we had to go up 1, which makes our y-coordinate a positive 1. And those are the only ordered pairs in this relation, so we're going to go ahead and use our brace to show that that's it for relation B. All right, so I think that I have given you a clue on what the definition of relation is, but we'll go ahead and define it. A relation is any set of ordered pairs. Now this is a very broad definition, which means that we can have a lot of things that are sets that are relations because they are a set of ordered pairs. They have 2 pairs, right? So for example, this could be a relation where we have brackets 1, 3, 2, 1, 7, 6, 8, 9. That is a relation because it is a set. It has the bracket, so it is a set, and it's a set of ordered pairs. It's a set of pairs, right? So that is a relation. Another example of a relation could also be this. Parentheses, dog, comma, puppy. That's one ordered pair. And then I have another ordered pair, cat, comma, kitten. So that is technically a set, because I have the braces, of ordered pairs, because those are ordered pairs. Another kind of even more interesting example of a relation, we can also do something like this. We can do parentheses, Ohio, Columbus. That is an ordered pair if you're writing it with an x coordinate and a y coordinate. Okay, so another ordered pair in this relation can be California, comma, Sacramento. My next ordered pair is going to be Georgia, comma, Atlanta. And then I close my set. So now I have a set of ordered pairs, which means I have, by definition, a relation. Okay, so sometimes we want to illustrate a relation. And if we want to illustrate a relation, we're going to use what's called a mapping diagram. So again, a mapping diagram illustrates a relation by showing two circles. All right. So one circle contains all the first coordinates, the x coordinates, if we will, and the other circle contains all the second coordinates, or the y coordinates, if you will. Okay, then arrows, it's kind of like a matching, right? Like, have you ever had to do matching on a test or a quiz? Arrows will show which coordinates are related. All right, so let's do an example of how that works. We're going to draw a circle mapping for the relations that we had in example 2. So let me pull back example 2. And this is actually example 3 that we're working on. So we want a circle mapping for relation A, right? And remember, relation A, if we go back to example 2, was the ordered pairs 1, 3, 3, 2, 3, -1, and 5, 4. Okay, so we're going to create a circle mapping for that relation A. So the first thing we want to do is we want to draw our two circles. I want to call this and name it A, right? This is circle mapping for A. And you're going to put all of the first coordinates in this first circle, but you want to make sure that you put the coordinates in numerical order. So we're gonna put in 1, 3 is repeated, but we only have to write it once, and 5. So we're gonna write 1, 3, and 5 because that's in numerical order, right? Now in our second circle, we want to write the numbers 3, 2, -1, and 4, but we want to put it in numerical order. So we're gonna write -1, 2, 3, and then 4. So now we need to draw arrows to show how are these coordinates related. Well, 1 is related to 3. So we're going to draw an arrow to show that 1 and 3 are related. And then 3 is related to 2. So we're going to draw an arrow from 3 to 2. And then 3 is related to -1. So we're going to draw another arrow from 3 to -1. And then 5 is related to 4. So we'll draw an arrow from 5 to 4. All right, so now let's continue with example 3 because we were supposed to do circle mappings for both relation A and relation B. So now let's do a circle mapping for relation B. Which, if we look back at example 2, relation B was 2, 1, and 3, 1. So again, we're going to draw our two circles. And this is relation B. So remember, our first circle contains our first coordinates, which are 2 and 3 in numerical order. So 2 comes before 3, so we're going to write 2 and then 3. And then our second circle contains all of our y coordinates, which is 1 and then 1 again. So we only have to write it once. We're just going to write 1. And then we draw an arrow to show the relation. So 2 is related to 1, so we'll draw an arrow from 2 to 1. And 3 is related to 1, so we'll draw an arrow from 3 to 1. And that is our circle mapping for relation B. So now we can think of a relation has 3 forms. Alright, so a relation has 3 forms. Okay, the first form is the set using the braces. Okay, and then listing the ordered pairs. That's the set. The second form is going to be the graph, when we graph the set of ordered pairs. And then the third form of a relation is the circle mapping. And you might think, well, why is the circle mapping important? A way to look at the form of a relation. Well, the circle mapping is going to help us look at domain and range. So let's first define what domain and range are. So domain is the set of first coordinates, which happen to go into the first circle, right? The set of first coordinates of a relation. Whereas a range is the set of second coordinates or the second circle of a relation. Alright, so let us try an example practicing domain and range. Okay, so we're going to do example 4 now. And what we're going to do in example 4, we're going to look at the 3 ways that relations can be represented, and then we're going to find the domain and range of each relation. And so we're going to kind of tie everything together now. We're looking at all 3 ways a relation can be, what form a relation can be in, all 3 forms. And then we're also going to do domain and range for those relations. So we're tying everything in together for these last questions. So example 4, we want to give domain and range. So first we have relation A, which looks like this. We have this circle, and it has 1, 2, and 8 in it. And we have this circle, which has 6, 7, 9. We're going to say that 1 is related to 6, and 2 is related to 9, and then 8 is related to 7. Okay, so we want to know what are the domain and what are the range. So for domain, when we list our domain and range, we want to make sure that we write it as a set. So the set for domain, which we're just going to call D, and we're actually going to take it a little bit more specifically. We're going to say the domain of relation A. So I'm going to put a little A underneath. It's a subscript because it's below. And we say D sub for subscript. So D sub A for relation A. So D sub A is equal to, and again, we're going to write it as a set. And remember, we want all of the first coordinates. Well, this form of a relation is a circle mapping. And remember, a circle mapping, all the first coordinates are in the first circle, and all the second coordinates are in the second circle. So if we want the domain, we just have to list the numbers in the first circle. So we have 1, 2, and 8 in the first circle. So those are our x values or our domain. For our range of set of relation A, so R sub A, we are going to list our y coordinates or our second coordinates or our second circle. So range would be 6, 7, and 9. All right, let's try a different form of a relation. Now we're going to do relation B, which happens to be a graph. So here's your y axis, and here's your x axis. And it looks like we have the points 0, 2. So right here. We have a point at 1, 1. We have a point at 2, 3. And we have a point at 4, 1. No, I'm sorry, 3, 1. 1, 2, 3, 1. So right here. All right. So we want to list our domain and our range. So D, our domain, sub B, so subscript B, or domain of relation B, we want just the x coordinates, right? Just the x coordinates. So if I'm going along the x-axis, at what points do I have a point? So let's see. I have a point at 0. Okay, so that's one of them. There's a point here. Moving along. Oh, I have one here at 1. So 1 is an x value. I have another point at 2. So that's another x value. And then I move along and I have a point at here. So that x value is 3. So now let's look for our range of relation B. So this one is going up and down, right? So starting here, let's go all, if I move up, oh, I have some points here, so that's 1. I move up again, here's another point at 2. Move up again, here's another point at 3. So those were my y coordinates. So now let's look at, so now that we've done a domain and range of a graph form of a relation, let's do a domain and range of a set form of a relation. So set relation C is going to be the ordered pairs 1, 2, 3, 4, and 5, 6. So when we find domain of relation C, or D sub C, we're looking for just the x coordinates, right? Or just the first coordinates. So this one, and this one. So we have 1, 3, and 5. Now when we do the range of relation C, we're looking for the second coordinates, or the y coordinates. So we get 2, 4, and 6. All right, that is your last example. Go ahead and try the problems on your own.